So last video for matrices, it is to use Cramer's rule to solve a system rather than the inverses that we learned last time or the reduced row echelon form that we learned a few lessons back. So supposedly we can get the solution to the system by finding the determinant of the determinant sub x, the determinant sub y, and the determinant of the main matrix, such that these values are here. And again, let's kind of see it in terms of an example. So for this system, the main D, this one, the denominator, is just the determinant of the coefficients. So D is equal to the determinant, notice just the vertical line, not the brackets, and it's going to be with the 3, -2, 6, and 1. That's obviously, this is only going to work if the determinant of this one is not 0, because it's going in the denominator in the formula. But this determinant is 3 minus 12. 3 minus a -12, or 15. And then according to this formula here, determinant sub x has st, which are the ends here, 4 and 13, and then b and d, the y coefficients. So you don't use the x's, and b in this case is -2, and 1. So I guess you could kind of think of this as the determinant without the x's is equal to 4 plus 26, or minus a -26, or 30, and the determinant without the y's is equal to, the st's comes second this time, and the ac comes first. 3, 6, and 4, 13. Now who figures this out? So 3 times 13 is 39, minus 24 equals 15. And so if we find those three determinants, then we can get the answer to this system by saying that x is equal to the determinant of x over d, 30 over 15, or 2, and y is equal to the y determinant, dy, 15 over 15, or 1. So x equals 2 and y equals 1. So obviously that doesn't seem super important, but if you were trying to program a computer to solve a system, that might be a nice quick way of programming it, as long as the determinant isn't 0. So the last thing to look at is how to use this Cramer's method to solve a 3x3 system, as opposed to doing reduced row echelon form. Unfortunately, it's a lot of work to find the determinant of a 3x3 system. Good practice. Let's go ahead and do one of them, and then I'll just give us the answers to some of them, or we could check it on the calculator, but if we're going to do it on a calculator, then we could just do reduced row echelon form. But anyway, so the determinant, if we find the determinant of these coefficients, and we may as well just use this row as our thing. This would be -1 raised to the 1 plus 1, so it won't change sign. So it'll just be 2 times this determinant, 2, 4, -2, -3, plus 1 but it's really going to be -1 because if it's the row 2, row 1, column 2, then well, we'd have this -1 raised to the row 1, column 2. Times the value that's in there. This would have had a -1 raised to the 1 plus 1, which just ends up being a positive. And then times the determinant if we cross this out, so it'll be -1, 4, 1, -3. And then a -1, row 1, column 3, and the -1 that's in there. And then we'll use these, -1, 2, 1, -2. And so this will be 2 times -6 plus 8. -1 times 4 minus 4. No, 3 minus 4, -1. And then -1 and +2 minus 2, 0. So this determinant ends up being 4 plus 1 plus 0, or 5. And then we could keep doing that, but this determinant is 15. This determinant is -10. This determinant is 5. If we'd been in class, I would have made kind of each group do one of those. And then according to Cramer's rule, the solution is the determinant dx, 15, over d, which is 5, so 3, and dy is -10 over d, which is 5, so -2, and 5 over 5, which is 1. So x, y, z. And notice the funny pattern here in figuring out what each of these are. This one is going to take, let's see, where's my other Cramer's rule? So this dx is replacing the 3, -3, 4. So the x's get replaced with the solutions, and then that's the remaining coefficients, 1, 2, -2. And for the dy, the y's get replaced with the answers, and then these are the remaining coefficients. And for dz, the z's get replaced with these end answers, and the rest of the matrix is these guys. So anyway, definitely tedious if you were trying to work it all out by hand, but Cramer's rule is a different way of solving a system using matrices than doing the reduced row echelon form. It would be good practice to type that into the calculator and do the reduced row echelon form for it to get that. Thanks for watching. Way to hang in there with all these matrices. The assignment that goes with this lesson has a little bit on Cramer's rule, but is mostly just a practice of all the things that we've learned in the matrices chapter.